Hey there, this is Math 2 Unit 5. We're going to go over the review worksheet today in preparation for your Unit 5 test. And so here we go. So first of all, it says what is the value of x? We're looking for the value of that angle right there. What we know about this shape so far is we know that we have an angle of 120 degrees there, right, or here. We have a 90 degree there, we have another 90 there, and another 90 there. So far, this is 27, 20, 29, 2. We have 390 degrees already accounted for inside of this shape so far. That's what we know so far. Now, in order to find out the sum of the interior angles, we need to use our little equation, which was 180 times n minus 2 to find out what value belongs kind of in this box. What's the sum? So this has a total of 1, 2, 3, 4, 5 sides. So we put 5 into here. Okay. We multiply 180 times 3 and 180 times 3. 180 times 3 is equal to 540. So now I know that the sum total of all the angles here is going to be 540, and I've already used up 390. So now I do 540 minus 390, and I get borrow there. 14 minus 9 is 5, and 4 minus 3 is 1, and so x is going to be equal to 150 degrees. Okay, and that is one of the answer choices. Number 2, it says determine the value of x. All right, determine the value of x here. Well, this looks like it's going to be loads of fun. So to determine the value of x, what we know is that, what do we know? That's a good question. What do we know? Well, we know that I have all of these together is going to add up to a certain value. All right, this is a quadrilateral. Now they're all different sides, different side lengths here, but the sum of all the angles together is going to be equal to 360. Okay, we know it's 360 because once again we could do the 180 times n, which in this case is 4 minus 2, and that becomes 180 times 2, which is 360. So we know that our interior measurement of interior angles is 360. That would mean that all of these add together to equal 360. So I can make a longer problem and say let's do 8x plus 1 plus 5x minus 4 plus 95 plus 73. All that together is going to equal 360 degrees. So I'm taking this plus this plus this plus this to equal 360. First I'll combine like terms. 8x and 5x becomes 13x. Okay, and then I can add up all these other numbers, and I have a 1 minus 4 plus 95 plus 73, which is going to equal 165. So 13x plus 165 equals 360. Okay, so then I subtract 165 from both sides. So 360 minus 165 equals 195. So 13x equals 195. We'll divide 195 by 13, and x equals 15 for the answer for number 2. And that's how we solve that one there. Okay, let's look at number 3. Determine the sum of the exterior angles of an octagon. Okay, the sum of the exterior angles of an octagon. Well, the sum of exterior angles of any shape is going to be 360. It's always 360. Whether it be an octagon or a square or anything else, I always end up with 360 as the sum of the exterior angles. Determine the measure of each interior angle, so each, keyword there, interior angle of a regular sided polygon with 9 sides. So in this case, what we're going to want to do is we take our equation, our little formula, 180 times n minus 2. That gives me all the angles inside of a shape, but if I wanted the each done, I divide by n. So now we'll use this information to plug in some values. This was a 9-sided shape, so we put 9 minus 2 there. and we divide by 9. 180 times 7 over 9, okay? And if I wanted to do the calculator, I can. I can do 180 times 7 equals 1260, and divide that by 9, and we end up with 140 degrees. So I have 140 degrees for the solution for number 4. Number 5 says determine the measure of each exterior angle of a regular polygon with 12 sides. All right, so we said back in number 3 that the sum of the exterior angles of every shape is 360. So now we just divide 360 by the number of sides. So we're going to take 360 and divide it by 12. And 360 divided by 12 equals 30. And so each angle would be 30 degrees. Number 6. The measure of an interior angle, so an interior angle, a regular polygon, is 162 degrees. How many sides does the polygon have? Notice it's regular, so that means they're all going to be the same measurement on the inside here. So that would mean that we take our equation, 180 times n minus 2, we don't know the sides, that's our n, is going to be equal to, well, we don't know that yet because n, since an angle is 162, we have n there is equal to 162. So this is what I would use to find out what the measurement of one angle would be, 162. So I'm going to move that over there by multiplying that. So I end up with 180, and let's just do the distributive. 180, that 180n, and then 180 times 2 is negative 360 equals 162n. Okay, I got that by doing distributing here and here, then multiplying the 3 to that side over there. So now I can subtract 162n, subtract 162n from both sides. So this becomes equal to 18n, and that's going to be equal to adding 360 over there is equal to 360. And now I do 360 divided by 18, and we find that n equals 20. So the number of sides would be 20. Alright, number 7. Here we have a shape with 1, 2, 3, 4, 5, 6 sides. So the sum of that measurement there, gotta figure what that is to figure out that piece, and then I gotta figure out the x piece, right? So, since it's not regular, we're gonna have to do this here. So we do 180 times 6 minus 2, which is gonna be 4. So 180 times 4, 180 times 4 equals 720. So 720 so far. Now I take that, that's the sum of the interior angles is 720. I've already used up, look here, we've used up 100, check, 100, check, 140, check, another 100, check, another 140 there. So we have 0, 8, 1, 2, 3, 4, 5, 580 is what I've used so far. So I'll take my 720 and I'll subtract the 580 that I've used. Alright, oops, don't need to borrow there, sorry about that. Borrow here. So 12 minus 8 is 4, and then 6 minus 5 is 1. So the angle measurement right here where this arrow is at is going to be equal to 140. And because this is supplementary, I'll do 180 minus 140, which gives me 40 for the value of x, or 40 degrees is the value of x. Alright, next problem. Let's turn the page and see what we have on the next page. Alright, here we are on page 2. It says find the number of sides for a regular polygon, notice it's regular, if each exterior angle has a measurement of 15 degrees. So normally, if we want to find out that each part, we would do 360 divided by the number of sides. In this case, we don't know the number of sides, but we know that the each becomes 15 degrees. Right? So if that's 15 degrees, what I can do is I can multiply the n over there, and I can divide the 15 over there, so it's like trading places there. So 360 over 15 is going to equal the number of sides. And 360 divided by 15 is equal to 24. So in this problem here, we would say that n equals 24. For number 8. Number 9. If f of h, this whole length here is 30. If that whole guy is 30, find f to k. Okay. Well, if the whole thing is 30, we have here a shape where these are being divided across, and we know that these are going to bisect each other. Because they're bisecting each other, that means that this length will equal this length. And if that's the case, then I do 30 divided by 2 to find out what the length of one of them would be, and that would be 15. And that's because this is bisecting, and those diagonal cross sections, when they bisect, give me portions that are equal to each other. So this matches this, and this one matches that one as well. All right, number 10. PQVT is a rhombus, which means these lines are all congruent. Determine the value of x. Determine the value of x here. All right, so if that's a rhombus, then what we know about a rhombus to be true is that we're going to take the angle measurement here, and we know that this plus that is going to add up to 180. Recognize this is only part of it though, so let's just start there. We know that we have 180 degrees between all of this, and I've already used up 110. So what's left is 70. This value here, because this is an angle bisector, is going to be half of it. So I do 70 divided by 2, and that gives me 35 degrees is the answer for the value of x. So again, 110 plus the 70, this whole thing is going to be 180 degrees. So that tells me that I take the 70 with the bisector, cut it in half to get 35. Number 11. What are the values of the variables in the given parallelogram? Alright, so let's take a look here at these values and how this works. First of all, because of the parallelogram, we know that these two angles are going to be equal to one another. That's the first thing that we can tell. So because they're equal to one another, we can say that 4x plus 6 equals 6x minus 8. So I'm going to subtract 4x there to get 2x over here, and I'm going to add the 8 over there. Add the 8 is for 14 equals 2x. Divide both sides by 2, and we have 7 equals x. So there's our first value, 7 equals x. Alright, so I have an option of this one or this one so far. Now I'm going to take that value and plug it in over here, because the sum of these two angles, because they're consecutive interior angles, should be 180. So let's plug the 7 in. We plug the 7 right there. There's my 7, right? 4 times 7 is 28. 28 plus 6, 28 plus 6 is going to be 34. So we know that's going to be 34 right there, because 4 times 7 plus 6 is 34. So 34, and we can write this here, so 2y plus 16 plus 34 is equal to 180. So we're taking that angle measurement plus a 34 to make it equal to 180. Combine our like terms. 16 plus 34 is going to be 50. We subtract 50 over here, and we're now down to 130 equals 2y. And so when we divide 130 by 2, we end up with y equals 65. Alright, so x is 7 and y is 65, which is only one of the choices there on our little table. Rule and property used to solve for. Well, how do we solve this? We said first of all that the opposite angles are congruent. We did that. And then we said that consecutive interior angles are supplementary. So 180 degrees, right? And that's how we solved it. All right, moving down to number 12. Number 12, if KLMN is a rhombus, so these all equal each other, And the measurement of KLM, if this thing right there is 70, what is the measurement of angle 1? This guy right there. Okay, well, when you have a rhombus, when their diagonals come across, we know that we make a perpendicular line right there. So that's 90. So we have a 90 degree in that space there. If this entire thing is 70 and it's a rhombus, that is an angle bisector. And since that's an angle bisector, half of 70, 70 divided by 2, is 35. Okay? So far I've used up 125 degrees inside this triangle. I have a 35 here and a 90 there, and all that's left is number 1. So we define that. We do 180 minus 125, and we'd say 7. 10 minus 5 is 5. 7 minus 2 is 5. And we have an answer of 55 degrees for number 12. Number 13. Which statements are true for a parallelogram? Select all that apply. Alright, let's see. Measurement of A plus B is 180 degrees. These would be consecutive interior angles. That would be a true statement. Okay, true. The measurement of A and C is 180 degrees. So A to C, nope, that would not be true. They would be congruent, but it doesn't mean that they're equal to 180 degrees. A equals D. Nope, that would be true if it was a trapezoid, right? If we had a trapezoid, an isosceles trapezoid, if that was the case, yes, then the base angles would be the same. But in this case, nope, not the case. BC equals AD. Because it's the parallelogram, we would say yes, that's going to be true. And angle A equals angle C, yes, that's true. Okay, so that's what we do there for number 13. All right, let's go to the next page. All right, for number 14, determine the length of KL in the trapezoid shown. All right, so what we said before is that this length, we can call that A, plus this length, we can call that B, is equal to 2 of this length here, which we can call C. Right, so we could write that out perhaps as something like A plus B equals 2 times C. So if my A is 4x plus 1, check, and my B is 27, check, and my C is 2 times 5x plus 2, okay, if I'm doubling the mid-segment, and I combine like terms, I end up with 4x plus 28 on this side equals, distribute property, 2 times 5 is 10x, and 2 times 2 is 4, and we're good there. Now we take the 4x and move it over there, so minus 4x, so we end up with 6x, and over here for the 4 we subtract 4 there, and 28 minus 4 is 24. We divide both sides by 6, and x is going to be equal to 4. Now to solve that, the property that we use, we would say would be the mid-segment property, which allows us to do what we just did. It shows that's 2 times those lengths added together. Number 15, if the measurement of A is 80 degrees, find the measurements of B, C, and D. Sure, we can do that. Notice here that this length 6 matches that length 6. When I have an isosceles trapezoid, which is letter B, right? What type of quadrilateral is this? We would say this is an isosceles trapezoid. When I have an isosceles trapezoid, then my base measurements are the same. So D would be 80 degrees as well. Now in terms of what the measurement up above would be, because I have consecutive interior angles, I would do 180 minus what I already have, 80, and find out that the measurements inside of here are 100, which would make that 100 as well. So my measurements are here, 80, 80, and 100, and 100, and those become my solutions for number 15. Number 16, determine the value of x and y. Alright, it's a little more complicated here, but we can certainly do it. Alright, so rectangle angles, we know that they have, these are 90 degrees in here. This is 90 degrees, no problem. So if that's 52, then what's left on the other side is 90 minus 52, which is going to be 38 degrees. 38 degrees. We also know that the diagonals produce isosceles triangles. The reason for that is going to be because it's rectangle, which would make this base also 38 degrees. Okay, and so if that base is 38 degrees and this is 52 degrees as well, 52, then we know that y is going to be equal to 38 degrees and x is going to be equal to, well, let's figure this out. I have 38 and 30 in the base, so that becomes 76. So I do 180 minus 76, and we end up with 104 degrees for the value of x. The rules for this that we would use is that rectangles, so rectangle angles are 90 degrees. It helped us solve that part there, which matches up. And diagonals are congruent. Okay, so we know those diagonals are congruent, and we talked about knowing what an isosceles triangle is. So those three things allowed us to solve that problem. Okay, number 17. ABCD is an isosceles trapezoid with mid-segment EF. Determine the following. We have to find N, which is there. We have to find out what those guys are there as well. We have a degree, we have 10 and 6. So what do we know? We know that A plus B, so 10 plus 36, which is 46, is going to equal the mid-segment times 2. So 2 times 3n minus 4. So this becomes 6n minus 8 equals 46. We add 8 over here to end up with 54 equals 6n divided by 6, and 54 divided by 6 is going to be 9, which is the value of n. Got that, no problem. Now to find the length of EF, we plug the 9 into that. So we have 3 times 9 minus 4. 3 times 9 is 27. 27 minus 4 is 23, and that's my length there. Over here, this becomes a sum of consecutive interior angles. So once again, we add that up. We have a 3x plus a 2x. So 3x plus 2x plus a 2x minus 17. So 3 and 2 is 5x. And 2 and minus 17 is negative 15. That's all going to equal 180 degrees. So we add 15, right? We have 195 equals 5x. And so x is going to equal 39 degrees. So 39 degrees there. And so we can take that value, right? Take that value and plug it into one of these. So we can plug it over here to the 2x. So we can say 2 times 39 minus 17. I do not know what 2 times 39 is, so we'll clear this and go 2 times 39 equals 78 minus 17 equals 61 degrees is the value for measurement of ADC. If this one is 61 degrees there, because it's an isosceles, then this measurement also is 61 degrees as well. Okay, so rules or properties there. We talked about consecutive for the x part to get this 39. Which one's that? The x is 39, which is this one. Yeah, to say what that x is going to be, we used the property that consecutive interior angles are supplementary. And then to get the n value, we use the mid-segment idea, which was that 2 times the mid-segment equals the base plus the top to get that solved there. Alright, so go to the next page. Okay, number 18. ABCD is a parallelogram. Determine the following. Okay, so parallelogram, this is going to be parallel with that line, and this line is parallel with this line here. Let's determine x and y values. Alright, we can certainly do that. Okay, so what we might want to do is say that x, for example, this will equal that. So we could say x equals 15 minus 3y. Okay, that's going to be a true statement. We could also say that 2x plus 9y equals 42. Alright, that's a true statement as well. So let's take a look here. If this is an x value, 15 minus 3y, that's what x equals. I can use that information and put it into this equation right there. So let's do that. We're going to do 2 times 15 minus 3y equals 2 times, 15 minus 3y, because that's not equals. 2 times, don't get confused here. So that's my x, 15 minus 3y, plus 9y equals 42. So all we did is we substituted for x here this value right there from our other equation. Now I'm going to use distributive property, and we have 2 times 15 is 30, 2 times negative 3 is negative 6y, plus 9y equals 42. I'm going to combine some like terms here, so 9y and 6y is a minus 3y. I can subtract 30 and subtract 30 from there, and 42 minus 30 is going to be equal to 12. I can divide both sides by minus 3, and y is going to be equal to negative 4. Now something seems a little bit off there in my solution. Let me think here. Oh, that's why. Sorry, back it up a little bit. This is a positive 3y, so don't worry about the negative part. That's a positive 4. 9 minus 6 is positive 3. So just got a little ahead of myself there. So y equals 4. Now because y is 4, I can go back into this other equation and plug that in there. So I can use the x equals 15 minus 3 times 4. 3 times 4 is 12, so 15 minus 12 is going to be equal to 3. And that's my value for x. So the way we did that was we said that opposite sides are congruent. And that's how we solve that, knowing that those are going to be equal and those would be equal or congruent to one another. Number 19. ABCD is a rhombus. Those all equal one another. Determine the following. All the A, B, C, D, X, Y, and Z. Great, we can do that. So to solve this here, let's start with our sides. Why not? This side is going to equal that side. So we could write down that 12n plus 20 is going to equal 15n minus 7. So we can subtract 12n, and end up with 3n left over here. We can add 7, and we can have 27 equals 3n, divide by 3, and so 9 equals n. Good so far, no problem. Now we have to find some angle measurements. Because this is a rhombus, their diagonals when they cross the middle are going to form 90-degree angles. That means y is going to be equal to 90 degrees right away, no problem. It also means that this one right here is 90 degrees as well, right? They're all 90 degrees. So, doing all right, 90 degrees, 90 degrees, 90 degrees, that's 90 degrees as well, not too bad. So, to find out what we're missing here, okay, what we're going to want to say is that z, because this is going to be an isosceles triangle, if you take a look at it, here the side lengths are the same, so this becomes my base, and my base for this triangle right there. There's the base, and there's a triangle. So if that's a 43, then z is also 43 degrees. So I've used a 43 at this base, a 43 at that base, which is a total of 86, and in a triangle I have 180 minus 86 for what's left up here at the top, and that's going to give me, oops, 7, 4, 94, not too bad so far, but I don't have 94 degrees here. This is an angle bisector, so I do 94 divided by 2, and 94 divided by 2 is going to be 47. So x is going to equal 47 degrees. So multiple steps there to get there. Lots of places make little tricky mistakes, so be very careful about that. Okay, so to solve for y, we said that diagonals are perpendicular. That's our sign for perpendicular. And to solve for n, we said that the sides are congruent, and that allowed us to solve that one there. All right, number 20. Number 20, it says for rectangle SPQR, find the coordinates of Q without using any new variables, and find the midpoints of PR and SQ. All right, so we went up a height of K to get here. which means this is also up a height of k. And we went out to C to get there, which means this is also out to C to get there. So we have C and K. In terms of the midpoint's going to be looking at going from we have the midpoint of PR. So here's P to R. So to find a midpoint, we're going to take our y, which is 0, minus our y1, okay, and we're going to divide that by 2, that's our y value, and our x value, sorry I should have done this first, is c minus 0 divided by 2. So that's our x and our x value and our y value. So c over 2, it becomes c over 2, just c over 2, and this one becomes negative k over 2 for the y value there. Right, negative k, let me think about this, just backwards, 0, oh, plus. No, yeah, difference. No, plus. We're going to add them up. We're going to add those values. Sorry. So positive. Now on this side over here, we would go with 0, our x value, our x value is 0, plus c divided by 2. And then over here, for the y value, is going to be 0 plus k divided by 2. So it was c over 2 again and k over 2 again when I reduce that down. Alright, so that's number 20 right there. Number 21, and find some more points here. Parallelogram AW in L, find the coordinates. Alright, so we know that the x coordinate for this one, it's on the y-axis, would be 0. Okay, we know the y coordinate is listed here at c, so this will be c. Over here, we're going to go out to an a value. This is negative a, which makes this amount a there, so I'd make that distance here b. So we'd say we're at point B there, and our y value, sorry, is 0. So I have 0c and b 0 for my different points. 0c and b 0. The midpoint of a n, so the midpoint of this to that. Okay, let's look at our x value. We're going to go 0 plus b divided by 2, and our y value is c plus 0 divided by 2. So we end up with b over 2 and c over 2. That's our first one. And then our second one here, we're going to have a negative a for x value plus a plus b over 2. And the y is going to be 0 plus c over 2. A's cancel, so I'm left with b over 2 equals c over 2. And again, those midpoints are going to be in the same spot, and that's because the diagonals are going to cross at that point because it is a parallelogram. Alright, let's go to the next page. Okay, this one here is a tad bit more complicated, so let's see what we have. First of all, we're going to plot the points 1, negative 1 for A, 2, negative 4, 1, 2, 3, 4 for B, and 4, negative 2, 1, 2, 3, 4, 1, 2, negative 2 for C. And we're going to plot that each time. So we're going to do that again over here. A, and then B was at 2, 4, 1, 2, 3, 4. And C was at 1, 2, 3, 4, and 2. And then we'll do it again over here. And go down and over there. We go up to there. Okay, so that's our initial point, just plotting A, B, and C. And I could label them, no problem, if you want to, A, and then B, and C, but you get the idea there. The next thing it wants me to do is A says plot a fourth point D in quadrant 4 that will make a parallelogram. Helps if you know your quadrants a little bit there, right? So quadrant 4, we start over here. If we count our quadrants up, we start on the positive side over here, and we're going to go around. Okay, this is quadrant 1, this is quadrant 2, over here we have quadrant 3, and here's quadrant 4. So to plot a fourth point in D in quadrant 4 means I got to put it over here. That's going to make a parallelogram. To make a parallelogram, they need to have lines that are the same slope from one another and things like that. So take a look at, for example, here I'm going down 1 and over 1, 2, 3. I can go down 1 and over 1, 2, 3 to put another point right there at point D to make a parallelogram. And so if I was to draw those there and connect the dots, we'd have a line, we'd have a line, we'd have a line, and we'd have a line. So the point there that would be plotted there would be at point 1, 2, 3, 4, 5, comma 1, 2, 3, 4, 5. 5, comma 5 is where I'm located at for point D. Okay? So explain why the quadrilateral formed is a parallelogram using the slope formula. Okay, so to explain why that is a parallelogram, what we'd want to do is, first of all, we know that to be a slope, we have to say that the slope of AC is going to be equal to the slope of BD. That's kind of our idea there. That's our slope. And the slope of AC is going to be down 1 over 3, so negative 1/3. And BD is down 1 over 3, negative 1/3. So that's the slope that shows that those two slopes are the same. And in terms of going from AB being equal to CD, AB has a slope of going down 1, 2, 3, and over 1, slope of 3. And CD is 1, 2, 3 over 1 is also 3. And so, I'm sorry, down 3, negative 3. So those slopes are going to be equal to one another, and that proves that it's a parallelogram, like so. Okay. For B, it says plot a fourth point D in quadrant 3. That's over here, quadrant 3. That will make a parallelogram. Okay, so same idea. I could look and say, well, here I'm going to go from this point and go 1, 2, 3, and up 1. I could take this point and go 1, 2, 3, and up 1, and put a point right there to have another point in that quadrant. This point is at negative 1 comma negative 3, right? So D is at negative 1 comma negative 3, and we have the points up there above. Explain why the quadrilateral form is a parallelogram using the midpoint formula. So midpoint means I'm going to be connecting my dots here quite a bit. So there's A, there's C, and there's B. So the midpoint, I want to show that AB comes together at a spot where DC also comes together at a spot. So I'm going to take my coordinates for A. A is 1 comma negative 1, and B, which is 2 comma negative 4. Okay, we're going to add the x coordinates up, 1 plus 2, and divide it by 2. We're going to add the y coordinates up, negative 1 plus negative 4, and divide by 2. So we have 3 over 2 there, and we have negative 1 plus a negative 4. It's going to be negative 5 over 2. So that's my midpoint for A and B. My midpoint for D and C. And D is at negative 1 comma negative 3. C, we said, was at 4 comma negative 2. So again, we're adding things, the x value, negative 1 plus 4 divided by 2. And the y value is negative 3 plus negative 2 divided by 2. So negative 1 plus 4 is 3 over 2. And negative 3 plus negative 2 is negative 5 over 2. Do they have the same midpoints? If those points match, if the points match, then that is the midpoint, and it is indeed a parallelogram. So we'd say, yes, that's going to be true there. Number C, letter C, plot a fourth point in quadrant 1 that will make a parallelogram. All right, so here we went up 1, 2 over 2. So let's go here and go up 1, 2 over 2 and put a point right there. So I'm just using some slope ideas to be able to plot this point. So whatever I do from here to here, I'm going to do from there to there, and then I'll make the point there, no problem. So now I have a parallelogram. Explain why the quadrilateral formed is parallelogram using the distance formula. Okay, so our distance formula, if you recall, is going to be our x2, right? x2 minus our x1 squared plus y2 minus y1 squared. Okay, so using our points again, here's A, and here is B, and here is C, and D happens to be at 1, 2, 3, comma 1. All right, so let's use our distance here formula to prove that it's the same distance from one place to the next. So AD should be the same distance as BC is the idea. AD should equal BC. So the distance for A from A to B, A to D, sorry. A is going to be, these are our stuff here. x2 will be our d value, which is 1. I'm sorry, it's 3, minus our a value, which is 1 squared, plus our y value for d, 1, minus our y value, minus 1 squared. So 3 minus 1 squared, 3 minus 1 is 2. So 2 squared plus 1 minus 1 is 2, which is again 2 squared, and square root of all that. 2 squared is 4. 2 squared is 4. So I have the square root of 8. And the square root of 8 is going to be the same as, well, I could think of this way. I've done this for a while probably. It's the same as 4 times 2. And what's the square root of 4 is 2. And there's nothing that's the square root of 2, so we leave it there. So I have 2 root 2 between A, D, and B, and C. Okay, so that's my distance there is 2 root 2 between those two lines right there. Now that should be the same distance as B and C, the same distance there. And so we could put those points in and see if that's the case, which it will be the case most likely. So we go root there, and we do B, which is going to be at, we're going to do our x2, sorry, so our C value is 4, minus our BX value is 2 squared, plus our Y, which is negative 2, minus a negative 4 squared. So 4 minus 2 squared is 2 squared, plus negative 2 plus 4 is a positive 2 squared. And so again, I'm left with square root of 4 plus 4, square root of 8, which becomes 2 root 2. So my distance between these 2 points is the same, so that partly proves that those are going to be part of it. I needed the same thing for A, B, and DC to prove that's the case as well. And if you do that, when you work it through, what you'll find is that DC is equal to square root of 10, and AB is also square root of 10. So you can do that on your own. I'm going to pause there on that part. Okay? Let's take a look at our next part. Determine whether each statement is always, sometimes, never true. A rectangle is a square. That would be a sometimes. It's not always, but it can be. A square is a rhombus. Rhombus means it has 4 equal sides. So that's going to be an always. A trapezoid is a parallelogram. To be a parallelogram, you have to have 2 sets of parallel lines. A trapezoid has only 1 set of parallel lines. So that would be a never statement. The diagonals of a parallelogram are perpendicular. Okay, that's going to be a sometimes. It depends on what we're talking about. If the parallelogram is a rhombus, then yes. If the parallelogram is a square, then yes. If the parallelogram is a rectangle, then no, it was not going to work. The sides of the parallelogram are congruent. That also depends. We would say sometimes. Okay, and let's look at the last page here. It says Samantha must prove this theorem. If AB equals DC and BC is congruent to DA, then ABCD is a parallelogram. Okay, so Samantha must prove this theorem. Let's see. AB equals CD and BC is DA because given information. Got it. AC equals AC by reflective property. Reflexive property. That's a true statement. So we can put that into our picture there. I'll slide this down. Sorry. 3. Triangle ABCD, ABC is congruent to CDA by what theorem? Well, by this theorem we would say it's by the side, side, side theorem, because we have a side and a side and a side. Okay? And then all this other stuff is there too. The question says which choice fills in the blank. The blank is asking for the side, side, side theorem, and that's all there is to it. That's it for today. Hope that helps you out. Good luck, and do great as always.